Morning. And this morning, we are taking a closer look at the coronavirus. By now, you have seen some images of the virus. There you go. Here is how this tiny spiky virus attacks a victim's lungs.
Sure, you've seen pictures of the coronavirus, but what really makes this spiky ball tick? It's too tiny to see with your naked eye, so you've got to think small. Picture just one strand of your hair and stretch that out. Imagine laying a dozen cells across the width of that hair. That's about how big some of your lung cells are. And next to a human lung cell, the coronavirus is still tiny, less than 1/100th of the width. The potent stuff's even smaller. The virus's guts, a strand of something called RNA. Similar to our DNA, this is genetic code, instructions for making copies of the virus. But to do that, the virus needs something it doesn't have. A cell. So it evolved a clever way to get inside yours. The key is the outside envelope and that crown of spikes that gives coronavirus its name. It's not decorative. This is an elaborate disguise, a fraud that the virus uses to trick its way in. You can think of your cell like a factory surrounded by a big fortress wall. The factory inside's making stuff your body needs, and all over the outer walls are special doors. Each door finds and pulls in specific stuff that the factory needs. This virus uses one door in particular, the ACE2 receptor, which normally grabs onto proteins and brings some of them into the cell. The spike on this coronavirus looks just like the real deal, but it's a Trojan horse. Once the receptor grabs that spike, the virus can fuse with your cell's outer wall and slip right through it, almost like a ghost. Inside the human cell, the virus starts uncoding, releasing its RNA. This starts a process that ends up using parts of the factory in your cell to make new copies of the virus, and more copies, and more copies. Those new copies start leaving the cell and can travel to other parts of your body to infect more. Scientists are studying the details of every step in this virus's life cycle. If we can find a way to interrupt just one part of it, it could lead to a new treatment or stop or slow the spread.